Select the schedules that would work for the digraph if only one processor is used. Let's take a look at the digraph here. So we have task 1 to task 3, and then to task 5, task 2 to 4, and then to 5. So that means that task 3 can only be started after task 1 finishes, task 4 can only be started after task 2, and then task 5 can only be started after all these are finished. And then task 6 and 7 could both be started after task 5. So really all we need to do is see if the schedule matches the rules of the digraph here. Okay, so let's start with this first schedule. So it says task 1, then task 3. That follows because it has to go that way here in the digraph. Task 2 and then task 4, that's next. And then task 5, after all those are completed. And then task 6 and 7. So this one definitely follows the rules of the digraph here. Now let's look at the next one. Task 1 and then task 2, that's fine. Those don't depend on each other. And then task 3 starts after task 2 is completed, which is also after task 1, so that still follows the rules. And task 4 started after task 1, 2, and 3 are all completed. Well, task 4 only depends on 2, and then that rule is satisfied. So the order is a little different here, but it still works out. And then task 5 is started after task 1 through 4 is completed, so that works. And then 6 and 7 are after. This one also follows the rules in the digraph. So look at this next one over here. It's task 1, then 3, that's fine. And then 2 and then 4, that's also fine. And then task 6, well, see, task 6 can only start after task 5 is finished, and that's not what the schedule shows. This shows task 6 before task 5, so this one doesn't work. Let's look at this last one here. Task 1, then 3, that's fine. And then task 4 starting before task 2, well, that's not right because it's supposed to go task 2 and then task 4, so this one doesn't work either. Okay, so that shows you how to determine whether a schedule matches a directed graph.